Today I'm going to talk about a new feature of Filibuster, compositional testing with service profiles. Now, the old Filibuster was designed so that you test all of your microservices together. This can be challenging if you work at an organization where it's difficult to run any more than a couple services or even a single service on your laptop because of the sheer number of services required to issue an end-to-end request and the amount of resources required to run all of the various queues and database dependencies that might exist. This compositional feature is important because it allows you to gain confidence in your application by piecemeal testing your services and then combining those services together without running the full application. And so in this example, we'll use a very small application to demonstrate this. So the application that we have today is composed of three services: an API service, a hello service, and a world service. API calls hello with a single RPC, which calls world with a single RPC before a response is returned to the end user. Now, for Filibuster, we're going to test for 5 particular gRPCs. Now, it's important with gRPC to realize that some of the gRPC error codes can be thrown for all gRPCs, like unavailable, unknown, deadline exceeded, where some gRPC error codes, like out of range, for instance, or not found, are error codes that the application can throw to indicate specific situations. This is similar to HTTP, how 404 or 500 you can experience on any endpoint when you make an HTTP call, but certain codes like 424, for instance, or similar might be, or I'm a teapot, for instance, 412, I believe that is, may only be returned if the application specifically asks for that code to be returned. So what we're going to do in this little tutorial here is we're going to test our application together to see what errors it can return, what are the application specific errors, and then we're going to test the services independently to first see that we don't reveal those application specific error codes when we test the services independently, but using Filibuster's new compositional testing component, we can recover that information, which allows us to test independently, but get the same results as if we had tested everything together when testing for error codes. So let's look at how our application works before we test it together. So 3 services: API, which talks to hello, which talks to world. When hello talks to world via RPC, any error it experiences when communicating with world will wrap that error in a data loss gRPC error and then propagate that upstream. When it propagates that error upstream, the API server will receive that. And if the API server gets a data loss error back from hello, it will return a resource exhausted error back to the caller of API service. And then if API server can't even communicate with hello, it will return a failed precondition. We're going to test for 5 errors. We're going to inject 5 different faults. Unavailable, which indicates the remote service is offline. Unknown, which indicates the remote service threw an exception like MPE or something like that. Internal, which means that gRPC had some sort of error in an interceptor or in its internal workings and threw. Unimplemented, which is the equivalent of a HTTP 404, which indicates the remote service, even though the protobuf said it should implement a method, has no handler for it. And then deadline exceeded, which indicates a timeout. So we're going to test all those services together. We're going to run them all together, test an end-to-end request from tests API to hello to world and back. And in my little test, I've encoded the errors I expect to see. And what I get are 10 different errors. So the first set of errors are resource exhausted errors because we injected a fault between hello and world, deadline exceeded, unavailable, internal, unimplemented, or unknown. Hello wrapped those in a data loss error and then propagated those upstream. And then when API service got a resource, when it experienced the data loss, it wrapped it in a resource exhausted and returned it back to the test. Similarly, if hello, we injected the fault in hello, the hello service, if we injected a deadline exceeded or unavailable or an internal or an unimplemented, when that fault is experienced by the API service, it wraps those in a failed precondition and returns those to the caller. Now, the only reason we've used all these different error codes here is just to make clear when you look at this output exactly where the errors are being generated. So we see that here's the fault we injected. Here's the error handler at hello. And then here is the error handler at API service. Again, here's the fault we injected at hello between API and hello. And here's the error handler that wrapped that at API service and returned it back from the test. And so what we see is when we test the entire service together, we get 10 different errors that the system experienced. And so in the next section, what we'll look at is why, when we test these services independently, we don't experience these 10 different errors in the same way. So now we're going to see what it looks like when we test our services independently. So we're going to start by testing the hello service using a mock of the world service. Now, when we write our mock, we're going to use a gRPC mock. It's a actual in-process server that just returns some static response. It's got no special stuff other than a sub-responsive world. And we're going to have hello talk to world. So when we test this, we're going to inject our 5 faults, and we get back 5 errors for our 5 faults that we injected. Remember, with Filibuster, each of these runs as an independent test. So we see we injected deadline exceeded. We got data loss wrapping deadline exceeded. We injected unavailable, and we got data loss wrapping and unavailable, and so on and so forth. So we injected our 5 failures, which tested hello in isolation with world. Now, if we test our API service using a mock of hello, we also get back 5. We see we get the failed precondition because we injected a fault between API and hello, and the fault we injected was our deadline exceeded. We injected an unavailable, and it was wrapped in a failed precondition, and so on and so forth. So we tested hello, we got 5, and we tested failed precondition, and we got 5. But did we test all of the scenarios that we need to? And the answer here is no. Because if we go back to our original test where we tested all of our services together, we never saw these resource exhausted errors. And this is because when we inject faults in hello, we don't know, unless we test the whole system together, we don't know that hello also returns a data loss error. And what we need to do to trigger these resource exhausted errors is to also inject this data loss failure. And so in this case, when we test API and hello together without world being online, we fail to exhaust all of the failure scenarios that we would test normally if we had tested all together. So how do we solve this? So with the new compositional feature of Filibuster, what we're going to do is when we test our hello service back here, Filibuster is going to generate what it calls a Filibuster service profile. And what that Filibuster service profile is going to do is it's going to look at all the responses that came out of hello when we were injecting failures, and it will aggregate those responses and write them out to the file system as a Filibuster service profile file. Now, what we expect is that developers will integrate this in CI so that those files are written out as part of CI, and those files are associated with the version of the application. So we can say, we tested version 1 of the hello service, and the version 1 of the hello service returned these possible application-specific error codes. So now what we can do in Filibuster is we can specify a path to our service profiles. Instead, we're interested in the fault behavior we observed as part of that service profile, and we want to inject faults based on that. And so what we'll do is we'll inject those 5 error codes that we saw before, but we'll also inject that data loss bug that we failed to test the original time. And what we see is with the use of the Filibuster service profile, we actually explore those other failure scenarios where we returned a resource exhausted error back from the API service because we injected the data loss bug, the data loss fault coming back from the hello service. And so this allows us to get the benefits of error code testing that you would get if you were testing your whole application by testing individual services and using the data you learn from one service to seed the testing of one of that service's upstream services. So the last bit I want to talk about here is a question of why we couldn't just inject all of the failures. And it is possible. We can inject all the failures. So rather than use this compositional approach, we could have just tested the API service with all of the possible gRPC error codes that might ever occur. And this is the approach that many companies take today. The reason for not doing this is because you're probably working on an application where a microservice makes 10 to 20 RPCs, and testing 10 to 20 RPCs for, let's say, 15 different error codes takes a lot of time. And this is especially complicated by the fact that if your code is dependent on certain RPCs failing, for instance, if I issue 10 RPCs, if RPC 1 and 3 fail, my application does something specific. If you have patterns like that, you need to test those 10 RPCs for the 15 different errors that it could return, and then you have to test all possible permutations. And these numbers get large really quickly. You have to test like 1 and 2 failing, 1 and 3 failing for all the different errors, 1 and 4, and then like 1, 2, and 3, 1, 2, 3, and 4. And so it can be quite expensive. And so the compositional approach allows you to basically test for just the application specific error codes that you're returning and save compute resources. And so what we like to see developers do is use the exhaustive error testing, if the compositional approach is not viable yet, because it requires that both services on either side of the call use Filibuster, and then move to the compositional approach to optimize and save compute resources once they do that. And so this just gives you another way of making your testing more efficient and moving some of your testing into the local environment to allow developers to start thinking about resilience early and often as they're building their application code. And so this has been an introduction to testing, compositional testing, using Filibuster's new service profiles.